In this example, we're going to discuss scaling up and scaling down in order to figure out and determine equivalent proportions. So looking at my two ratios here, I have 9 miles for every 2 hours and then 63 miles for an unknown amount of time. What I need to do in order to determine how many hours there would be when there's 63 miles, say I'm going on a run and I'm able to run 9 miles in 2 hours. If I were to run 63 miles, how many hours would that take me? I need to figure out that scaling up factor that helped us convert from 9 miles to 63 miles. So in order to go from 9 miles to 63 miles, I would have to multiply by 7. So whatever I did to the numerator, just like with equivalent fractions, I would have to do the denominator. And for 2 hours, I would have to multiply that by 7 as well. So then 14 hours would go in the denominator for 63 miles when I'm traveling on foot, on my run, if I'm running at the same speed consistently. Now my ratios on either side of the equation are equal because I use that same scaling up factor of 7. Now, in some cases, you might have to scale down. You might be given a ratio where a ratio in an equation where you'll have to scale down rather than scaling up, and this is one such example. So there I have $9 for every 6 gallons. So if I was buying gas, $9 for every 6 gallons of gas. I want to know how much it would cost for 3 gallons of gas. So I would have to figure out, how did I go from 6 gallons to 3 gallons? Well, in order to do that, you'd have to divide 6 gallons by 2. So whatever you do to the denominator, you would have to do to the numerator. So I'd have to divide that by 2 as well. And 9 divided by 2 is 4.5, so it would be $4.50 for 3 gallons of gas. So that's how you would use scaling down, and dividing by 2 would be my scaling down factor in order to find that equal proportion. So that's how you scale up and scale down in order to find equivalent proportions.